Okay, so yesterday we had started this notes page, covered the majority of it, but there was one property on this notes page that we skipped and we were saving here for today. The homework assignment from yesterday was this worksheet, but only these problems here in purple. The homework assignment today is going to be doing all the remaining problems that you didn't do yesterday. I believe it's these problems here that I have highlighted in yellow. Okay. So let's take a look at this one property here that we had skipped yesterday. Okay, this property is called the one-to-one property. If you want to just make a note to yourself here that this property applies to equations. Okay, this is the property that exclusively deals with equations. And the way that this works is in the name one-to-one property, it kind of tells you the circumstance or the situation that needs to exist in your equation in order for you to be able to apply this property. Okay, so I'm going to give you an example. Let's say that you have log base 4 of 81, and that is equal to log base 4 of 3x. Okay. According to the one-to-one property, as long as you have one logarithm on the left side of the equation and there are no other terms, and you have one logarithm on the right side of the equation, no other terms, and those logarithms both have the same base and they have coefficients of 1, then you are permitted to cross off the log and the small base, leaving behind only the arguments that are equal to each other. Okay? So if we cross that off, we are left with the equation 81 equals 3x. We would continue just solving that algebraic equation. We would get x equals 27. Now, there is one thing that you have to watch for when you are solving logarithm equations. There is a domain restriction. So I'm going to write this up here at the top of the paper. We'll talk about what this is and then how you kind of have to check for this with all of your equations that you're solving that have logarithms in it. Okay, here's your domain restriction for logs. Okay, I'm going to abbreviate here. A logarithm's argument can't be 0 or negative. Okay, you could try this on your calculator. If you just press the common logarithm button, the log button where we know that means the base is a 10, and you can try to type in that the argument would be 0. Okay, if you did that, it's going to give you an error or say that it's undefined. You could also try to type it in where maybe it has a negative argument. Okay, you're going to get a very similar error. Okay, so this is a really important domain restriction, kind of like when we have fractions. We can't allow the denominator of our fraction to be a 0 or it's undefined. This is a specific restriction on logarithms. They only are considered defined if their arguments are greater than 0. They cannot be 0, they cannot be negative. So when you are solving these equations and you get to the end, we'll go back to this example we just did here with the one-to-one property, and you get your answer that x would equal 27. What you have to do before you technically circle that as your answer is you need to take 27 and ask yourself if you were to plug it back into the original problem where the logarithms were still there. If you plug that back in for the x's, would that create any argument that would either be 0 or a negative argument? If the answer is yes, then you need to throw that answer out. If that's the only answer you have and you're throwing it out, you would then write down no solution. But we can see that if we plug a 27 in for the x, 3 times 27 is not 0 and it's not going to be negative, so we're going to keep 27 as our answer. Okay, so we're going to try to apply this one-to-one property to the two equations that we have on the back of the notes page. And you'll notice it mentions here, watch for your domain restrictions. That's what this means when it says to check your answers. It's reminding you here that the arguments of the original problem have to be positive. Okay, they have to be positive. Now, I very likely gave you guys the quadratic formula program on your calculator. You're welcome to use that for some circumstances that are going to pop up in these few examples here that you're going to see. If you don't have the quadratic formula program on your calculator, I will also mention as we go through this an alternate way that you could essentially do these problems. Okay, so here's where we want to start. As soon as you see that it is an equation, meaning we've got an equal sign here on your problems, you need to think, I need to apply the one-to-one property. Okay, once again, the one-to-one property, in the name, it kind of tells you the situation you need to create. You need to make sure that you have one logarithm on the left side and one logarithm on the right side, and that there's nothing else extra over there. Okay, we can see on this particular example, this is already set up where we nicely have one log on each side. Okay, the next thing we need to make sure that the bases of each of those logs are both the same. We can see these both have a base of 2, and we need to make sure that the coefficients of those logs are 1. We can see that's the case as well. All right, so we are set to apply the one-to-one property, which says you're allowed to cross off then the log and the tiny subscript base, only leaving behind the argument on the left equaling the argument on the right. Okay. Now, when we did this example on the front, I'm just going to scroll back here so you can see. When we crossed off those logs, we were left with 81 equals 3x. That was not a quadratic equation. There was no x squared, so it was just linear. We just divided by 3. We got our answer. If you notice that you have an x squared, though, in your equation, this means this is quadratic, like what we studied back in chapter 4. And we talked about lots of different ways of solving quadratic equations. We had the graphing method, the factoring method, the square root property, completing the square, and quadratic formula. Okay, what I'm going to do is I'm going to move everything to one side of the equation. I'm going to put it in descending order. So we're going to bring that 7x over, rearrange it. Since the focus in this section, in this chapter, is more on logarithms, this is why I have given you the quadratic formula program on your calculator. Okay, so it is totally fine for you to run the quadratic formula program on your calculator. Okay, if you have it on your calculator, what you're going to do is you're going to press the black program button. The black program key is, kind of in the middle of the calculator there. It says PRGM. You're going to press that. It's going to give you an alphabetized list of any of the programs that you have on your calculator. Now, you would have to deliberately have this put on your calculator, which is what hopefully I have already done for you in class. But if you don't have it on your calculator, I'll mention an alternate way that you could do this. But if you have it, you're going to press that program button. You're going to select, usually it's called quad or quad form. You're going to select that program and hit enter. Okay, now when you run the program by hitting enter, it's going to ask you what is A, you're going to type that number in, what's B, and what's C. Well, for this particular problem, the A value you'll enter is a 1, the B value is a -7, and the C value is 12. You don't enter the X's at all, just the numbers. You're going to hit enter, and it's going to report the two numbers that are your solution to this quadratic equation. Should be numbers 4 and 3. Now, if you don't have the quadratic formula program on your calculator, this was an easy problem for you to factor. You know, this could be factored, two numbers that are multiplying to be 12, but adding to be -7. Now be careful, the two numbers are not the two solutions. That's what you plug into the factored version, and then when you set those equal to 0, you end up getting the same two solutions you get if you ran the quadratic formula program. Okay. My advice, though, is not all of these problems are you going to be able to factor. So my suggestion to you, if you do not have the quadratic formula program on your calculator, would be to take the equation, type it into y1, graph the parabola on your calculator, and use the feature that we learned in chapter 4. You press second, calculate 0, and you move the cursor to the left, to the right, and guess, and then do the same thing over here, and it will give you those two x-intercepts. Okay, so if you don't have the program, graph the parabola, find the x-intercepts. Now, it does mention we have to check our answers. So we got to look back at the original problem that has the logarithms in it. You have to say to yourself, if I substituted a 4 in for this x, would that cause this argument to either be 0 or negative? The answer is no. If we plugged a 4 in over here, would this argument be either 0 or negative? Again, no. Okay, we want to do the same thing with a 3, plug in a 3 in. Notice I'm not actually plugging it in, I'm just kind of looking at this and saying that's not going to make that 0 or negative, nor would plugging a 3 in over here make that 0 or negative. So I should have checked that first before I actually circled this as my official answer here. Okay, so let's try one more. This one's a little bit more complicated. You're going to have to be careful because not all of the problems are going to start out where there's already just a single logarithm on each side. You can see that in this example, we have 2 logarithms on the left side of the equation and 1 logarithm on the right side. Okay, do not move logarithms across the equal sign. Leave things stationary where they're at, but according to the 1-to-1 property, we should not be crossing off any logarithms until we have combined together so that we have 1 logarithm and only 1 log on the left and 1 logarithm and only 1 logarithm on the right. So we talked in yesterday's video about how to combine logarithms. We said the circumstances have to be such that the bases are the same. You can see these bases here are both a's, and the coefficients have to be 1s. And we don't have a 1 on this first logarithm, but we did learn the property called the power property, which allows us to drag that coefficient up as the exponent on the logarithm's argument. Okay, so I'm going to pull that on up. I don't need to do anything over here on the right side, so I'm just going to recopy that down. Okay, now I'm going to pay attention that I'm adding these 2 logarithms. When I add logarithms, what I'm technically doing, I'm technically going to multiply the arguments. So I'm multiplying x squared and 2 so that the argument is 2x squared. And now I've got this set up where I can move forward with the 1-to-1 property. I've got 1 logarithm on the left, 1 on the right. They have the same base. They have 1s in front. So I'm allowed now to cross off the log and the base. Do not, at the beginning of this problem, be crossing off 3 logarithms. There is never a situation where you would cross off 2 logs from one side and 1 log from the other. You always combine things together, clean it up, so there's 1 log on each side of the equation. Okay, I'm left with 2x squared equals 5x plus 3. I see again, this is a quadratic equation, so I'm going to move the 5x, move the 3 to the other side of the equation. I'm going to run the quadratic formula program. A is 2, B is -5, and C is -3. If you have the program, go ahead and run it. If you don't have the program, then type this into Y1, graph it, and find the x-intercepts. You can pause this video if you want to go ahead and try that to make sure that you're coming up with the right numbers. Okay. Either way, the x-intercepts or running the quadratic formula program, the answers should be +3 and -1/2. Now, be careful. Just because these answers here are negative, or if one of them is negative, that's not a reason to throw an answer out. An answer gets thrown out if when you plug that number back into the original for the x, it makes one of the arguments a negative or a 0. Now make sure when you're plugging these back in, it needs to be in the original even before you've pulled up this 2. So let's start with the 3. If I plug a 3 in, I'm good here. If I plug a 3 in here, yep, this is not going to be negative or 0. So I'm definitely going to keep the 3. What about -1/2? Well, if I stick -1/2 here, that argument is going to be a negative. So I don't even need to check it over here on this side. Even if it worked out fine on this side, if you find one argument that it's going to be negative or 0, that's a reason to throw it out. This answer is only x equals 3. Okay, make sure you're very careful. The last 3 problems on your worksheet tonight are equations. Make sure you have 1 log on each side before you cross off the logarithms. Okay, the assignment is to do these remaining problems on the worksheet. As always, just reach out if you guys have questions.